understand a little fun about that outrageous thing we're going to discuss today, can't you?
Yeah, oh yeah. This hearing will come to order. Good morning. I'd like to welcome everyone to today's hearing of the House Committee on Science and Technology entitled Geoengineering, Assessing the Implications of Large-Scale Climate Intervention. I believe this hearing marks the first time that a congressional committee has undertaken a serious review of proposals for climate engineering. That is not surprising because this is a very complex, controversial subject that has had little formal debate in the United States. Geoengineering carries with it a tremendous range of uncertainties, ethical and political concerns, and the potential for catastrophic environmental side effects. But we're faced with the stark reality that the climate is changing and that the onset of impacts may outpace the world's political and economic ability to avoid them. Therefore, we should accept the possibility that certain climate engineering proposals may merit consideration and, as a starting point, review research and development as appropriate. At this time, or rather, it is best geoengineering, or at its best, geoengineering might only buy us some time. But if we want to know the answers, we have to begin to ask the tough questions. Today, we begin what I believe will be a long conversation. In fact, my intention is for this hearing to serve as the introduction to the concept of climate engineering. Over the next 8 months, the committee will hold 2 or 3 more hearings to explore underlying science, engineering, and ethical, economic, and governance concerns in fuller detail. I'm pleased to announce that this will be part of an interparliamentary project with our counterpart in the United Kingdom House of Commons Science and Technology Committee. When members of the Commons Committee visited us last spring, the chairman, Phil Willis, proposed that we work together on issues of common interest. Geoengineering has decidedly global implications, and research should be considered in the context of transparent international process. Yesterday, the Commons Committee voted to undertake a parallel effort to examine the domestic and international regulatory framework that may be applicable to geoengineering. We will be in close contact with them, sharing the findings from our own efforts. When they complete their work in the spring, the chairman of the committee will testify before us in a hearing on domestic and international governance issues. But before we begin this discussion today, I want to make something very clear up front. My decision to hold this hearing should not in any way be misconstrued as an endorsement of any geoengineering activity, and the timing has nothing to do with the pending negotiations in Copenhagen. I know we will run the risk of misleading headlines. However, this subject requires very careful examination and will likely only be considered as a potential stopgap tool in a much wider package of climate change mitigation and adaptation strategies. It will require years of international coordinated research for us to better understand our options, to examine the impacts, and to know if any activity warrants a deployment. In the meantime, nothing should stop us from pursuing aggressive long-term domestic and global strategies for achieving deep reductions in greenhouse gas emissions. This issue is too important for us to keep our heads in the sand. We must get ahead of geoengineering before it gets ahead of us, or worse, before we find ourselves in a climate emergency with inadequate information as to the full range of options. As chairman of the Committee of Jurisdiction, I feel a responsibility to begin a public dialogue and develop a record on geoengineering. And with that, I look forward to a good, healthy discussion, and I turn it over to my distinguished ranking member, Mr. Hall, for his opening statement.
Mr. Chairman, I could make the shortest opening speech in history of this committee.
Okay.
I could say, geoengineering, hello, but I won't do that. I will just say to you that I thank you for having this, holding this hearing today, and once again, the Commerce and this committee in their duties are taking on issues that are really the forefront of cutting-edge science, and I appreciate your leadership. As many of my colleagues will agree, the debate about climate change is far from over. I'm sure that you conducted and participated in that and came to the conclusion that there was a fact that there are still many opinions as to the causes, the effects, and the potential solutions. demonstrates how much uncertainty there is out there and how crucial it is for our nation to continue to search for answers. Geoengineering, or climate engineering, is in, I guess, the intentional modification of the Earth's environment to promote habitat, to promote, and just go to the definition and see that it's so broad that you could apply the term to almost any human changes that are made by humans in their surrounding environment, from building dams to deforestation. The actions are more local or regional in scope. The types of modifications we'll be discussing this morning are global in nature, and therefore, no matter what our preconceptions are, the implications of such technologies are far from reaching and are far-reaching. I understand that the hearing is to be the first of a series of hearings on this topic, further exploring the scientific basis underpinning the concept of geoengineering and the ethical concerns and issues surrounding any future development and deployment scenarios could be extremely helpful in advancing the discussion about geoengineering. I'll reserve my full judgment on this issue until all the facts are in, but have to admit that I'm a bit skeptical about this non-traditional approach. I know that our witnesses here today represent a variety of different viewpoints on geoengineering, and I'm eager to listen to their thoughts about the issue. I'm sure that we'll have plenty of questions to ask them, and I really look forward to a very lively discussion. I expect we're going to have one. And so I think I have to thank you again, Mr. Chairman. This kind of opens up, you know, Alfred Hitchcock did The Birds. You remember that movie? And I've been working all since that time on a movie to have the elephants, flying elephants, you know, like Hitchcock had those birds that were going to disturb the whole world. And I don't know if I can get that underway or not, but we maybe work that in some of this here. But I'll yield back to my chairman, James Bond, and I thank you very much for letting me talk.
Well, Professor Shepard, welcome to America. If there are other members who wish...
I knew that'd get me in trouble.
If there are other members who wish to submit additional opening statements, your statements will be added to the record at this point. And now it's my pleasure to introduce our witnesses. Professor John Shepard is a professional research fellow in Earth System Science at the University of Southampton and chair of the Royal Society Geoengineering Working Group that produced the report Geoengineering, the Climate, Science, and Governance Uncertainty. And the University of Southampton is not located in New York. Dr. Ken Caldeira is a professor of environmental science in the Department of Global Ecology at the Carnegie Institute of Washington and co-author of the Royal Society report. Dr. Lee Lane is the co-director of the American Enterprise Institute for Public Policy Research and of Geoengineering Project. And Dr. Alan Robock is a professor at the Department of Environmental Science at the School of Environmental and Biological Sciences at Rutgers University. Dr. Robock, Mr. Rothman wanted us to give you his best. He is ill today, but wanted to be with you. And Dr. James Fleming is professor and director of the Science, Technology, and Society Department at Colby College and the author of Fixing the Sky, The Checkered History of Weather and Climate Control. As our witnesses should know, we will have 5 minutes for your spoken testimony. Your written testimony will be included in the record for the hearing. And when you have completed your spoken testimony, we will begin the questions. Each member then will have 5 minutes to question the witnesses. So we begin in the order. Dr. Caldeira. Caldeira, excuse me. Yes, sir. Well, I'm reading from my report here, and so you are first in that regard. But if you'd like to yield to Dr. Shepard, then we will do that. Okay, so if you'd turn on your mic, then we'll all be better off.
Chairman Gordon, Ranking Member Hall, members of the committee, I thank you for giving me the opportunity today to speak with you about why it makes sense for us as American taxpayers to invest some of our hard-earned dollars in exploring ways to cost-effectively reduce environmental threats that are facing us. I'm a climate scientist working at the Carnegie Institution Department of Global Ecology. I've been studying climate and ocean acidification for over 20 years and investigating geoengineering options for more than 10 years. Climate change poses a real risk to Americans. The surest way to reduce this risk is to reduce emissions of greenhouse gases such as carbon dioxide. We can build a 21st century energy system based on solar and nuclear power, along with carbon capture and storage from coal, oil, and gas-fired power plants. I believe we can and will make this transformation to the clean energy system of the future. However, even if we decide to start building our 21st century energy system today, because of the long time lags involved, we will still face threats from climate change. The options we're discussing today can be divided into two categories with very different characteristics: solar radiation management approaches and carbon dioxide removal approaches. Solar radiation management methods, which you could also call sunlight reflection methods, seek to reduce the amount of climate change by reflecting some of the sun's warming rays back to space. We know this basically works because volcanoes have cooled the Earth in this way. Preliminary research suggests that we could rapidly and relatively cheaply put tiny particles high in the stratosphere and that this would cause the Earth to cool quickly. Nobody thinks these approaches will perfectly offset effects of carbon dioxide. For example, these methods do not address the problem of ocean acidification. However, preliminary climate model simulations indicate that these approaches could offset most climate change in most places most of the time. While these approaches may be able to reduce overall risk, they could and likely will introduce new environmental and political risks. In contrast, carbon dioxide removal approaches seek to reduce the amount of climate change and ocean acidification by removing carbon dioxide from the atmosphere. Essentially, these options reverse carbon dioxide emissions into the atmosphere by pulling carbon dioxide back out of the atmosphere. There are two basic types of carbon dioxide removal methods. One is to use growing forests or other plants to store carbon in organic forms. The other is to use chemical techniques. We could build centralized carbon dioxide removal factories or perhaps spread out finely ground up minerals that would remove carbon dioxide from the atmosphere. With the exception of proposals to fertilize the oceans, carbon dioxide removal methods are unlikely to introduce new unprecedented risks, so cost is likely to be the primary consideration governing deployment. Let me mention in closing that I do not think the term geoengineering is very useful in informed discussions. The term has been used by so many people to refer to so many different and poorly defined grab bags of distantly related things that I do not believe the term can help us to think clearly about the decisions we need to make. So to conclude, we need multi-agency research programs in both sunlight reflection methods and carbon dioxide removal approaches to find cost-effective ways to protect American taxpayers from unnecessary environmental risk. Because these two basic approaches, the solar radiation management approaches and the carbon dioxide removal approaches, differ in so many dimensions, it seems unwise to link these research programs closely together. Solving our climate change problem is largely about cost-effective risk management. There are many different ways that risk might be diminished, and the most important of these is to reduce greenhouse gas emissions. However, we also need to improve our resilience so that we can better adapt to the climate change that does occur. We also need to understand whether there are ways that we can cost-effectively remove carbon dioxide and perhaps other greenhouse gases from the atmosphere. Lastly, we should try to understand whether thoughtful, intentional interventions into the climate system might be able to undo some of the damage that we are doing with our current inadvertent intervention. The problem is too serious to allow prejudice to take options off of the table. I thank you for your attention, and I would be happy to answer your questions.
Thank you, Dr. Caldeira. And Professor Shepard, you recognize.
Good morning, Mr. Chairman, Ranking Member, members of the committee, ladies and gentlemen. Thank you very much for the invitation to come and testify to you this morning. It's a privilege to have that opportunity. And my testimony will be largely based on the Royal Society study that you mentioned, Mr. Chairman, which was undertaken over the past year and which I chaired. The report of this study was published in September, and it's available on the Royal Society's website, and printed copies have been made available to the committee. The aim of this study was really to try and produce an authoritative and wide-ranging review to reduce the confusion and misinformation which exists in some quarters about this rather controversial and novel issue, in order to enable a well-informed debate on the subject. And so it's a great pleasure to me to be here at the beginning of such a debate, and I hope that our work will be useful. The working group was composed of 12 members, mainly scientists and engineers from the UK, but also included a sociologist, a lawyer and an economist, and one member from the USA, Dr. Caldeira on my left, and one from Canada. And the members of the group were not proponents of geoengineering. They reflected a very wide range of opinions on the subject, and all recognize that the primary goal is to make the transition to the low-carbon economy that Dr. Caldeira has already mentioned, which we shall need to do eventually irrespective of climate change, simply because fossil fuels are a finite resource. So our terms of reference were to consider and, so far as possible, to evaluate proposed schemes for geoengineering, which we took to mean the deliberate, large-scale intervention in the Earth's climate system, primarily in order to moderate global warming. And the study was based primarily on a review of the literature, but also by a call for submissions of evidence, of which we received some 75. Since time is short, I would like to move directly to summarize the key messages of our study. And first among these is that geoengineering is not a magic bullet. None of the methods that have been proposed provide an easy or immediate solution to the problems of climate change. There is a great deal of uncertainty about various aspects of virtually all the schemes that are being discussed. So at present, this technology, in whatever form it takes, is not an alternative to emissions reductions, which remain the safest and most predictable method of moderating climate change. And in our view, cutting global emissions of greenhouse gases must remain our highest priority. However, we all recognize that this is proving to be difficult, and in the future, given adequate research, geoengineering may be useful to support the efforts to mitigate climate change by conventional means. We concluded that geoengineering is very likely to be technically possible, but there are major uncertainties and risks with all methods concerning not only their effectiveness, but also their costs, their unintended environmental impacts, and the social consequences and mechanisms needed to manage them. So in our view, this is not a technology which is ready for deployment in the immediate future. It is, however, a technology that may be useful at some point in the future if we find that we have need of it, but it will not be available unless we undertake the necessary research, not only on the technology, but particularly also on the environmental and social impacts of such proposals. And to do that, we need to have a widespread public debate and widespread public engagement, and especially to develop an acceptable system of governance. Geoengineering, by intention, will affect everybody on the planet because it is an intentional moderation of the environment, and consequently everybody has an interest in the outcome. And we need to find a way to engage the opinions of a very diverse group of people on the planet in order that this can be done in an orderly and acceptable manner. Dr. Caldeira has reviewed the major differences between some of the methods, which I support entirely, And I would say finally that too little is known about the technologies at this stage to pick a winner. What we need is research on a small portfolio of promising techniques of both major types in order that our plan B will be well prepared should we ever need it. Mr. Chairman, thank you very much.
Thank you, Professor Shepard. And now, Mr. Lane, you're recognized.
Chairman Gordon, Ranking Member Hall, other members of the committee, thank you very much for the opportunity to appear here this morning. I'm Lee Lane. I'm a resident fellow and head of the AEI Geoengineering project. The American Enterprise Institute is a nonprofit, nonpartisan organization that engages in research and education on issues of public policy. AEI does not take organizational stances on the issues that it studies, and the views that I'm going to express here this morning are entirely my own. I want to begin by warmly commending the committee for convening this hearing. And my statement fundamentally urges that you treat this session as a first step toward embarking upon a serious, sustained, and systematic exploration by the U.S. government of research and development into solar radiation management in particular, one of the two approaches to climate engineering discussed by Dr. Caldeira and Dr. Shepard. Solar radiation management, or SRM, as the committee has heard, envisions offsetting man-made global warming by slightly raising the amount of sunlight that the Earth reflects back into space. In a recent study, a panel of 5 highly acclaimed economists, including 3 Nobel laureates, rated R&D on solar radiation management concepts, 2 solar radiation management concepts, as the first and third most productive kinds of investment that can be made in dealing with climate change. Now, the panel that did those rankings was well aware of the large uncertainties that continue to surround solar radiation management, and they were also aware of the fact that, in the long run at least, solar radiation management cannot replace the need for greenhouse gas emissions reductions. But at the same time, the panel was clearly very much aware of the vast potential that solar radiation management has. One preliminary assessment is that SRM, if deployed, might well produce savings in terms of reduced damages from climate change in terms of $200 to $700 billion a year. So we have potentially a good deal of upside with this technology. The cost of an R&D effort into solar radiation management is likely to be minuscule in comparison with these potential benefits. SRM research is needed in part because, for many nations, steep reductions in greenhouse gas emissions cost more than the perceived value of the benefits of making those reductions. The record of the last 20 years of climate talks amply demonstrates that the prospects for steep emissions reductions on a global scale are poor, and they're likely to remain so for an extended period of time. Yet, without such emissions reductions, and perhaps even with them, some risk exists that quite harmful climate change might occur. An SRM system might greatly reduce the potential for harm. SRM, it is true, carries some hazards of its own. An R&D program, though, provides the best chance of gaining the information that might be needed both to assess the prospects of SRM in a more knowledgeable way, and also perhaps to find ways of minimizing those risks in the future. At this point, the top priority should be to gain added knowledge about SRM. Eventually, the U.S. may wish to address questions of international governance, but at this point, our first goal should be to learn more about about solar radiation management as a tool. I guess the single most important caution that I would like to leave with the committee is that the governance arrangements for any research program, including one on solar radiation management, can either serve to nurture R&D success, or they can serve to stifle it. And I think it's awfully important as we go forward in considering how we want to manage research and development into SRM, that we keep in mind the need to balance the risks and the benefits of how we structure our R&D efforts. Thank you very much.
Thank you, Mr. Lane. Also, thank you for being an early supporter of ARPA-E. We hope that that some of the research that will come out of ARPA-E will mean that this potential review will be moot.
I hope so, too.
Dr. Robock, we welcome your discussion.
Mr. Chairman, Mr. Hall, members of the committee, thank you for inviting me. First, I'd like to agree with Ken Caldeira that global warming is a serious problem and that mitigation, reduction of emissions should be our primary response. We also need to do adaptation and learn to live with some of the climate change, which is going to happen no matter what. Using geoengineering should only be in event of a planetary emergency and only for a temporary period of time, and it's not a solution to global warming. Could I have the first slide? I've done climate. I'm a climatologist. I've done climate research and effects of volcanic eruptions for 35 years. We did a climate model simulation of what would happen if we put in the equivalent of one Pinatubo volcanic eruption every 4 years. That's the green line is the global warming temperatures that we've seen up until now. The black line is one Pinatubo every 4 years. The brown line is one Pinatubo every 2 years, assuming that you could do it. This brings up several questions. What temperature do we want the planet to be? Do we want it to stay constant? Do we want it to be at 1980 levels? Do we want it at 1880 levels? And who decides? What if Russia and Canada want a little bit warmer and India wants a little bit cooler? If we stopped after 20 years, we'd have rapid warming, as you can see. We did it for 20 years. And this rapid climate change would be much more dangerous than the gradual change we would get without doing anything. So this is a couple of the reasons why I'm concerned about it, but we certainly need more research. Now, how do we get the aerosols? I'm talking about the solar radiation management. How do we get the aerosols into the stratosphere? There's no way to do it today. Ideas of artillery or balloons or airplanes need a lot of research. Ken said it would be easy and cheap, but there's no demonstration of that. It might not be that expensive, but such equipment just doesn't exist today. So I've made a list of 7 reasons why it benefits for stratosphere geoengineering and 17 reasons why it might be a bad idea. Now, volcanic eruptions produce drought in Africa and Asia. They produce ozone depletion, no more blue skies, less solar power. And each of these needs to be quantified so you policymakers can make a decision about whether or not to implement it. We don't have quantification of any of these yet. I disagree with the economic analysis because they just ignored many of the risks and didn't even count what the possible dangers might be. So, but I agree with everybody that we need a research program so we can quantify each of these so policymakers can tell is there a plan B in your pocket or is it empty? We really need to know that, and we don't know the answer to that yet. If we were going to test putting particles in the stratosphere, we don't have a system to observe them. The U.S. used to have a series of satellites called SAGE, which looked at particles in the stratosphere. It was very useful for monitoring volcanic eruptions, and they stopped working, and there's no plan to put them up there. So we need this system anyway to monitor the stratosphere for the next volcanic eruption and to monitor it if we ever do experimentation. if we wanted to do experimentation, it would, it's not possible to do just a small-scale test, put a little bit of particles in and see what would happen. We could do that, but we couldn't measure their effects because there's a lot of weather variability, a lot of weather noise, and so we'd really have to put a lot of material in for a substantial period of time to see whether we're having an effect. And that would essentially be doing geoengineering itself, that you can't do it on a small scale. You could fly a plane up there and dump some gas out and see what would happen at the nozzle, but to do a full-scale experiment, we can't, a small-scale experiment, we couldn't do it. For example, if there's already a cloud there, we want to put gases in and see if the particles, we get more particles, you can't do that if there's not particles there already. We may just make the particles bigger. And so it's problematic whether we could actually ever do an experiment in the stratosphere without actually doing geoengineering. So I'd like to urge you to support a research program into the climatic response with climate models, into the technology to see if it's possible to develop different systems so that we can make an informed decision in the future. Thanks.
You, Dr. Robock, and Dr. Fleming, you're recognized.
Thank you, Mr. Chairman, Ranking Member Hall, and members of the Committee on Science and Technology. I want to talk about history, and one of my epigraphs is that in facing unprecedented challenges, which I think we are, it's good to seek historical precedents. History matters, and informed policy decisions are going to require interdisciplinary, international, and intergenerational perspectives. So I applaud your international move, and I'd like to make a case for intergenerational perspectives as well, informed by history. I was once asked when humans first became concerned about climate change, and I immediately responded in the Pleistocene. That is, our whole history comes out of Ice Age variations of climate, and all of human history lies within the last interglacial era, which is 12,000 years ago. We've experienced huge variations in climate, up to 27 degrees Fahrenheit. And I'm sure the early humans had important tribal councils, too, to talk about these things, although they didn't have mitigation yet as an option. European explorers and early American settlers were surprised that the New World was so much colder than the areas of the same latitude in Europe. For example, Washington, D.C. is on the same parallel as Lisbon, Portugal. Colonists worked to improve the climate by cutting the forests, tilling the soil, and draining the marshes. Benjamin Franklin thought this was possible. Thomas Jefferson thought it was actually happening. He called for an index of the American climate, which is one reason we have great weather records in this country, to document the changes being caused by human intervention. I'll show a few pictures. The quest to control nature, including the sky, is deeply rooted in the history of Western science. Some climate engineers claim they are the first generation to propose the deliberate manipulation of the planetary environment. But history says otherwise. In the 1830s, America's first national meteorologist, James Espy, who worked for the U.S. Army Surgeon General, advanced a large-scale engineering proposal to emulate, quote, artificial volcanoes. He proposed lighting huge fires each week. He preferred Sunday evenings. All along the Appalachian Mountains, each week he was going to make it rain and control and enhance the nation's rainfall. Espy argued that the heated updrafts would trigger rain and would not only eliminate droughts, but also temperature extremes, and would render the air healthy by clearing it of miasmas. A popular writer at the time, Eliza Leslie, pointed out that manufactured weather control would generate more problems than it solved and would satisfy no one. This is 1842. This image of a technocrat pulling the levers of weather control appeared on the cover of Collier's magazine in 1954. We were in a weather control race with the Soviet Union at the time, and an Air Force general had just announced to the press that the nation that controls the weather will control the world. The magazine article inside by President Eisenhower's weather advisor, Harold Orville, provided detailed ways of conducting weather warfare. A year later, the noted Princeton mathematician Johnny von Neumann, in an article called Can We Survive Technology, wrote that climate control through managing solar radiation was not necessarily a rational undertaking. In his opinion, climate control could alter the entire globe, shatter the existing political order, merge each nation's affairs with those of every other, and lend itself to forms of warfare as yet unimagined. He compared climate control to the threat of nuclear proliferation. Here, Archimedes is acting as a geoengineer, and technology is his lever. But where is he standing, and where will the earth roll if tipped? Geoengineering is not cheap, since we don't know the side effects. Quoting Ron Print of MIT, How do you engineer a system you don't understand? While some argue that we can control the temperature of the globe, ironically, at a recent NASA meeting on the topic of managing solar, a meeting coordinator apologized for not being able to control the temperature of the room. Think about it. This is Hurricane King, 1947, when Project Cirrus intervened and seeded it. They wanted to announce to the press that they could control hurricanes, but basically they canceled the press conference when it came ashore and devastated Savannah, Georgia. Other diplomatic disasters include Project Storm Fury in the 1960s, where Fidel Castro accused America of cloud seeding over Cuba, and Vietnam, Operation Popeye, when the UN subsequently outlawed hostile use of weather modification. People have said that climate control is not a good idea. Harry Wexler, the head of research at the Weather Bureau, said this in 1962. And just 2 years ago, Bert Berlin, the first chair of the IPCC, wrote, "The political implications of geoengineering are largely impossible to assess, and it is not a viable solution because in most cases it's an illusion to assume that all possible changes can be foreseen. Climate change is simple. We should do the right thing. Climate is complex. It's involves oceans and atmospheres, ice sheets, and now monsoons. So studying the human dimension is essential. We need the interdisciplinary, international, and intergenerational emphasis." Thank you for your time.
Thank you, Dr. Fleming. At this point, we will begin the first round of questions, but first I would like to give a premise. Listening to the panel makes me think that for most people, this is like coming in to after the intermission to Mr. Hall's movie about the elephants, and that we might want to give a little bit more of a premise. And I would really advise anyone that has an interest in this issue to review the Royal Society's report. It's very good. I was thinking about giving Mr. Hall the two-page summary, but I didn't want to overwhelm him. So. Professor Shepard would,
You'd have had to read it to me.
Professor Shepard, just quickly, would you sort of remind everyone about the volcano in Pinatubo in 1991 and what happened? And I think that's a good foundation for everyone to know.
Thank you. The volcano emitted a large amount of sulfur dioxide, amongst other things, some of which made its way to the stratosphere. And the result of this was the formation of a natural sulfate-based aerosol that spread very rapidly around the world and lasted for a couple of years, causing a fall in temperature of approximately 1 degree Fahrenheit for a couple of years. So this gives us some confidence that aerosols in the stratosphere do have a cooling effect, and that the quantities of material required to do this are not unthinkably large. However, volcanoes, of course, emit a lot of other stuff as well as sulfur dioxide, and so they're not a perfect analog. And one of the other issues in relation to...
Well, I just wanted to sort of point out that really nature has already given us somewhat of a model, and this is not completely out of line.
I don't really understand him yet.
I'm going to give the panel some questions to take home with you, and I would like a response later. But let's just start a discussion with, and if we could today, because if we're looking at a research program, I'd like to get a little better idea of what we should do. And so let me put out some questions for the panel and get some reaction. And again, I would like for you to take it back and respond to us later. But what would be the critical features of such a program? Would there be just one coordinated program in the U.S.? Which U.S. agencies would have to be involved from the start and which would need to play a later role? What scale of investment would be necessary both initially and in the long term? And what kind of expertise would be required? I'll later ask about the international implications, but I'd like to get your thoughts on a research program here in the United States. Who wants to start? Yes, sir, Dr. Fleming.
I think based on what I said, we'd have to have a lot more humanists involved, a lot more social science component. And I know that the National Academy has done things, but it's the National Academy of Science. And so I'd like to recommend that we go multi-agency, but include not only technical outfits in the discussion.
Okay. Well, then we'll just go down the hall. Professor Shepard, and then Caldeira, and then Lane, and then Robock.
Yes, I would suggest that the program has to be international and that it should not focus exclusively on one technology, and specifically that it should not focus exclusively on solar radiation management, because that is a technology which requires you to maintain your activity for as long as the greenhouse gases stay in the atmosphere, which is several centuries to 1,000 years. And it's not clear that human society has the ability to sustain an activity on that timescale. So I think it would be very dangerous to start solar radiation management without having figured out your exit strategy, and your exit strategy would almost certainly include one or other of the carbon dioxide removal methods. So I would suggest that a small portfolio of methods of both of these types should be researched in parallel.
Dr. Caldeira.
I would like to suggest that we should be thinking in terms of several research programs, each multi-agency in character, but led by different agencies. If we separate the solar radiation management proposals from the carbon dioxide removal proposals, I think the solar radiation management proposals, the research should perhaps be led by NSF, possibly NASA. On the carbon dioxide removal approaches, again, can be divided into two major classes. Some are essentially growing plants and burying the organic carbon made by plants. We already have some research programs into growing new forests and similar techniques, and those programs could perhaps be expanded to encompass a broader range of biologically based methods to remove carbon dioxide from the atmosphere. The Department of Energy is already leading projects to remove carbon dioxide from gases coming out of power plants. That those programs could be expanded to also consider removal of gases from the atmosphere. And so I think there's at least 3 separate programs, and some of them might involve expansion of existing programs on the carbon dioxide removal side, but there's really no program at all on the solar radiation management side. And I personally would like to see NSF probably lead it, although NASA might make sense as well.
All right, let's move to Mr. Lane.
I would suggest that, is this on?
Yes.
Yeah. I would suggest that the solar radiation, first of all, let me agree with Dr. Shepard that I think there ought to be research in both families, both air capture and solar radiation management. However, solar radiation management offers much larger economic payoffs potentially, and a much greater ability to reverse rapid, highly destructive climate change should that occur. Therefore, I guess I would reverse Dr. Shepard's judgment of priorities and say that of the 2 approaches, solar radiation management deserves more attention, and as Dr. Caldeira has suggested, it's not really receiving any support from the U.S. government at this time. It is clearly the sort of problem that is going to require multiple agency inputs, and poses a very difficult organizational challenge for combining science and engineering.
I'm going to let everybody respond in writing later, but Mr. Robock, if you would maybe just quickly close us.
First of all, I'd like to mention that although the Pinatubo volcanic eruption cooled the planet, it also produced drought in Asia and Africa. It destroyed ozone, and it reduced solar radiation generation from direct solar radiation by 30% in those technologies that we're developing. So it's a lesson of efficacy, but also of problems. I think research into solar radiation management needs to be done in a coordinated way internationally with climate models. The National Science Foundation should probably take the lead in the U.S. along with NOAA and NASA. There also needs to be a research program into the technology. Can we actually get particles into the stratosphere? And probably NASA, the A is Aeronautics, and the Department of Defense might be looking into the technology of it, whether it's possible.
Thank you, and now I yield to Mr. Hall for rebuttal.
I always come out second on that one. When you're the chairman, you got the gavel. I'll be serious with you because I appreciate you and appreciate your background, the many years of study, and the gifts you've made to this country, and your very appearance here today makes me even more appreciative of you. And I especially like Dr. Shepard, Professor Shepard, because he at least discussed global warming, and he added the term cost to it, and that's what we can't get hardly anybody to talk about, or who's going to pay it, or how much China's going to continue to pollute the world and not pay $1 and increase it on an increasing ratio. So thank you for that. I agree with you on that. I don't disagree with you on anything you've said. I just don't fully understand it. But he's given me the right to write you, and you'll be hearing from me. Thank you. Mr. Lane, you said you advocate research and not deployment. I guess that's what I'm trying to say. And would you expand on your comment and your testimony that a steep decline in greenhouse gas emissions may well cost more than the perceived value of the benefits? And let me say before that we had a study. I chaired one of the committees one time when we were studying, and we studied about asteroids. A professor told us about volcanoes, but we were studying asteroids and the danger and trying to get an international thrust on them. Got no help on that because we had I think about $1.5 million budget on that, and that was a couple of brilliant people and their workers, co-workers with them. But we learned during that hearing something that none of the group knew, including the chairman, that was me, that an asteroid just missed the Earth about 15 minutes sometime in 1987 or 1988. So I think this is worthwhile, and I was just spoofing the chairman. He's so good-natured. He's the only chairman I can kid like that. But go ahead now and answer me if you would, Dr. Lane. Dr. Lane.
Yes, sir. It seems that the last 20 years has shown not only that it's difficult to get agreement on greenhouse gas controls, but that's happening for very clear reasons. China and India both have very rapidly growing emissions, and yet it's clear from the way their governments are dealing with the negotiations that they do not perceive greenhouse gas emissions reductions, at least not steep ones, as being in their national interests. And both of those countries are too powerful to coerce, and the costs of bribing them to reduce emissions when they don't feel that it's in their national interests are likely to be prohibitively high. I don't want to give the impression that I believe that we can go on emitting greenhouse gases at ever-increasing rates. I don't. I think eventually controls are going to be essential. But I really strongly believe that the conditions are not in place yet for a global agreement on significantly reducing emissions. And until those conditions are in place, there really isn't very much that the United States can do to change the global trajectory of emissions.
Well, I thank you for that. And also, I guess I'd ask you, your testimony seems to suggest at the time that it is R&D and not implementation. And are there entities, organizations, or countries that see an urgent need for implementation versus a process of R&D? I know most of the really rabid advocates of global warming mention everything but the cost, and mention everything but the fact that China's, I think, every 6 days are spewing not using clean coal. And I think we'll fall back on coal one day. We're going to have to, but it has to be clean coal. But that they're increasing, again I say, on an increasing ratio, the damage to the earth without paying anything. And that goes for them, that goes for Russia, it goes for India, it goes for Mexico, and you could go on and on of those that want the benefits of the work that you probably all believe in, but don't want to participate in the cost. One of the others of you made mention of that. I'll let you have whatever. I think I have maybe 2 seconds left, but if you can do your best to give.
I do support R&D rather than deployment. Dr. Robock is absolutely right. We don't have the technology yet to do deployment, nor would it be prudent. For me personally, if I were going to put my bet on where to do R&D in the U.S. government, along with NSF that Dr. Caldeira mentioned, I would suggest that DARPA might have a role.
Thank you, Mr. Hall. I think we can submit that unanimously that this panel would say that there should be no deployment, only research. I don't think you're going to find anybody that's going to disagree with that. Dr. Baird is recognized.
Thank you, Mr. Chairman. I thank our panelists. Roughly how much CO2 do human beings put into the air, anthropogenic CO2, on a daily basis? Anyone have an estimate of that? Or annual, if whatever numbers? Dr. Caldeira?
The average American puts out something like their own average body weight each day in the form of carbon dioxide, so something like 150 pounds of CO2 per person per day in the United States.
Times 300 million people.
Right, times 365 days a year.
Uh-huh. Mr. Robock, did you want to add to that? The reason I ask the question is we are doing geoengineering on a massive scale. I mean, if 100 years ago somebody had said, hey, here's a bright idea, we should promote a plan to put that much carbon into the air, and Dr. Caldeira, I commend you for mentioning ocean acidification, 25% of which will go into the oceans, make the oceans 30% more acidic within 50 years, and then continuing on after that to make it so acidic that it reaches levels not seen since the age of the dinosaurs and dissolve coral reefs. Shouldn't Congress support that? People would say, you're crazy. That geoengineering on that scale, which is what we are doing, and now we're looking at ways to reverse that. Second observation would be, years ago there was a psychologist named Elizabeth Kubler-Ross who looked at what happens when people are dying, and not everybody goes through her stages of dying, which got a lot of play at the time, but nevertheless her stages of dying went, denial and then bargaining. And the bargaining tends to be, isn't there going to be someone to come rescue me from this cancer or this other illness that I've got? It strikes me that we're sort of in those stages now. And the reason I raise that in the context of geoengineering, we've had a whole series of hearings in my committee and this committee, or my subcommittee and this full committee, on carbon sequestration, on nuclear fusion, on geoengineering, and it seems to be everybody's trying to say, isn't there some way out there that we don't have to make changes in our behavior, that we can continue to spew just as much CO2 or use just as much energy, and something somewhere is going to save us from just having to make these horrific changes like turning down our thermostat, putting air in our tires, etc. And so I applaud you all for suggesting that we're not going to have this deus ex machina rescue us by, chemtrails or whatever people want to distribute into the air. There are some positive things, though, we could do. What would be the impact of simple things like changing the color of roof shingles or painting the rooftops? My rooftop here in town is black. It's a black rubber surface. It gets hot as blazes up there. I'm told we could make substantial differences in temperature and energy consumption. Not on the scale we need. It's not enough. But the point is, piece together the small stuff that doesn't require massive interventions. What are some of the things we could do?
Actually, if we put solar panels on our roofs, that would be a much better way to respond, because we would produce electricity from the sun, and that would reduce the amount of CO2 emissions from other sources. And that would be much better than just painting the roofs white. It would cost a little bit more money to start with, but in the long run it would be the best investment, and it would be a business opportunity. Why doesn't every new house have solar panels built into the shingles rather than retrofitting it like I did on my house, thanks to subsidies from the state of New Jersey? So there's lots of little things we can do, and they all add up to a mitigation plan.
We focused mostly today so far on atmospheric and solar radiation management. What about in water? I mean, we're also geoengineering our water system. We're putting hundreds of billions of pounds of effluent and fertilizers, et cetera, in the water. What are some positive changes that we can do to agricultural practices, runoff practices, et cetera, that could help improve the quality of our water? Not dumping clay into as a flocculant of algal blooms, but some positive things to reduce them from occurring to begin with. Do any of you have comments on that? Or are we mostly atmospheric today? I mean, you get the point I'm trying to make here, that we are causing the problem through our own behavior, and then we're somehow going to try to fix the Earth instead of fixing ourselves. If you had to summarize that, which would you say, because my time's running out, which would you say is easier, change our behavior or change the planet? Dr. Shepard?
Well, you're making it into a black and white choice, and my answer would be both. And the problem is that there is an awful lot that we could do in Europe, in the US, and in China and everywhere to reduce the impacts that we are having. But however hard we try, that may not be enough. So I think it's a mistake to make it black and white and say it's either or. I think we need to do both, and that may at some stage involve geoengineering.
My time's expired.
Thank you, Dr. Baird. And Dr. Bartlett, Dr. Elders is recognized.
Thank you, Mr. Chairman. I appreciate the interesting interaction we've just had. I'm not quite sure what Mr. Baird meant when he talked about fixing people. I know a lot of people fix their dogs and cats, but on the other hand, that might be part of a good solution.
Professor, do you remember the name of that woman that wrote that book?
No. Anyway, I'm hearing this discussion. I'm very much reminded of Garrett Hardin, who's a great environmentalist, and he had a statement which I framed and hung on my wall for a while. You can't do just one thing, and that's the heart of the issue we're facing here today. I think we have a lot of good ideas, a lot of things we might want to try. But you can't do just one thing, and almost everything you do has side effects. Some may be good, some may be bad. Frequently you don't know until you've tried it. And that's what's going to be the major impediment here as we proceed. There's also a public attitudinal problem that, well, the best example I can give you, in the 1973 gas shortages, when we had the big long gas lines, and as a physicist, I was very interested in people's attitude toward energy, and I felt we could do a much better job of conserving energy. The response of most people, even in talking to me, would say, well, we really don't have to worry about this. The scientists will come up with a solution. This intrinsic faith that science can solve mammoth problems like that is not probably, well, it's nice they think that much of me, but I don't think it's realistic. I think we have to face these problems in all of their dimensions. And the point was made about China and India and what their attitude is going to be. As long as we continue the current economic behavior of this nation, we have no leverage in which to try to solve the environmental problems. I mean, how can we threaten the Chinese? Say, if you don't do this for us, we're going to stop borrowing money from you. I mean, that's not an awful lot of leverage. So I think you have to keep all these factors in mind. I'm not in the least bit skeptical about geoengineering. I think that's something we really have to investigate. I am skeptical about saying this is the answer to a major problem until we get some data, do some experiments, find out what works and what doesn't work. And above all, continue to recognize you can't do just one thing. And I remember very clearly, I'm showing my age by this, but in the era when everyone believed we could shoot silver iodide up into the atmosphere and make rain wherever we had a drought spot. And we seriously pursued this in some arid areas of our nation. Found it just didn't work well because we have a lot of side effects we didn't anticipate. So this is a bit more of a sermon than a question, and you're welcome, any of you who wish to can feel free to comment on this and how you think our nation and other nations can address this problem in a thoughtful, reasonable, meaningful way to try to come up with some solutions of geoengineering that would work. Any comments? Yes, Dr. Caldeira.
I think you're correct in that we can't do just one thing, and that I think everybody on the panel here believes that we need to eventually get to an energy system that does not use the atmosphere as a waste dump for our industrial products, but that there's a potential for some of these methods to reduce the risks that we're facing and reduce these risks cost effectively. And while the panel disagrees about maybe the scale and scope of what a research program should be, I think it's indicative that the entire panel asserts the need for a research program. And I would just also like to take this opportunity to support something Alan Robock said before when I was talking about the structure of research, that on the solar radiation management side, there's an environmental science component that might be NSF, but there's another component about developing and engineering hardware that might better fit in the agencies that Alan mentioned. Thank you.
Dr. Robock.
I'd just like to say that we can't hold geoengineering as a solution and allow that to reduce our push toward mitigation. It's never going to be a complete solution. We may need it in the event of an emergency, but let's not stop mitigation and wait and see if geoengineering would work. That's not the right strategy.
Well, on that line, I think it'd be very important for us to continue very strongly the approach of reducing our use of fossil fuels. For example, I've advocated for years that we try to move to solar shingles. That every house has to be built with solar shingles.
We don't really need all these lights on in here either.
No, we don't.
Well, the cameras wouldn't work as well. Dr. Ehlers, if you don't, I'm going to be a little more strict because we're going to have votes, unfortunately, in a few minutes. So
it's amazing how the clock runs so much faster when it's my time.
Well, it's also moving up, not down.
Thank you. Thank you.
Dr. Griffith, you're recognized for 5 minutes.
Thank you, Mr. Chairman. I appreciate this opportunity, and I do think the initial discussions of this subject are important, even though we may not reach a conclusion. We do know we have a wide diversity here with the life expectancy of the male in China of 73 and the life expectancy of the male in India of 63, which points out a great disparity in what the needs of the various countries are, and it makes it greatly difficult for a country like the U.S. That represents only 5% of the world's population to come to a conclusion or reach an agreement on how we should approach or sell ourselves to the rest of the world. I guess if we included Germany, France, and England in that population group, in Denmark we may get up to 6 or 7% of the world's population. So it's a good subject, and it's certainly necessary, and I appreciate each and every one of you being here, and I appreciate the chairman bringing the subject up. I think this is a start, so thank you.
Thank you, Dr. Griffiths. Dr. Bartlett's not here right now. We'll recognize him when he gets here. So, Mr. Smith, you're up to bat.
Thank you, Mr. Chairman. I'll try to be brief. This is my 3rd year here, and it's been interesting being on the science committee and trying to sift through the science and whether something is peer reviewed, whether it's not, and the rejection of recommendations that our science is peer reviewed. So it's been for this Nebraskan interesting, and how we might contribute, and especially as it relates to industry in my district. And if any of you could speak to the impact, your perceived impact of livestock industry. I've heard various accusations, and if any of you would care to comment on that.
I'm no expert on the livestock industry, but I do know that one of the concerns with respect to livestock and global warming are methane emissions from livestock. And I know that people are working on various ways of removing methane from gases that might be in barns or pens where livestock are held. And it might be potential for the kind of research to remove greenhouse gases from the atmosphere in general also to be applied to facilities such as livestock pens or barns.
Thank you. Anyone else?
Yeah, I'm involved with the University of Kansas in a group that's doing this interdisciplinary graduate education, and certainly it's one of your neighbors. But the group there is getting technical training in agricultural sciences as well as techniques to mitigate or perhaps reduce some of this. But part of the group's also looking at behavioral issues and choices and ways of working together with the industries to advance their purposes as well as other goals. And so the point I was making is that I think that the education we have often is in content and technique of science or techniques of engineering, but that social dimension is very important. And so looking at issues like global warming and making personal commitments and personal decisions, I think is a very significant aspect of this program. It's not a solution to the beef issue, but if smoking is bad for you or beef is bad for the planet, people have to make some decisions or alignments.
Are you suggesting that beef is bad for the planet?
No, but others have. It's been in the news recently.
Well, I did read comments of a writer one time who said that eating a T-bone steak is more egregious to the environment than driving a Hummer, per se. I was astounded. I'm not sure the nutritional values were considered, in the
That's right.
In the bigger picture, but certainly there's some concern, especially amidst this economy, that in the so-called mitigating efforts, whether it's cap and trade, which is called a lot of other things, or whatever approach we might take, I hope that we remember that we need to look at the big picture economically, that there are some important factors here. Dr. Caldeira?
We don't know how well these methods will work, these solar radiation methods will work at affecting regional climates. But there's at least some possibility that as a result of climate change, weather conditions will change in America's heartland and that this will impact on the production of grain. And, I would be misleading you if I said, I thought we could reverse this. But I think there's at least a potential that a research program with a relatively small investment could understand, if the American heartland does turn into a dust bowl, is there a potential to change weather patterns to allow us to engage in agriculture once again? And so even if there's a small probability that this will occur, the investment is small, and so the expected benefit of this investment is very high.
Mm-hmm. In my part of the country that I represent, we had an extended drought, and now we have certainly a wet October. Is that wet October a result of climate change and the carbon emissions?
There's a lot of weather variability that because of the chaotic nature of the weather. So you can't attribute any drought or any flooding event to global warming. The probability of different weather events changes over time, but certainly that's just part of normal weather variability.
Okay.
But cows do put a burden on the climate system. There's the methane emissions and there's all the energy used in the production of beef, and so that is one of the mitigation strategies is for people to eat less beef, and maybe there could be a way for your constituents to gradually transition to other things that they could do that would be emit less greenhouse gases.
I'm sure that's the answer you wanted to hear, Mr. Smith.
If only my time had not expired. Thank you, Mr. Chairman.
Ms. Cosmas is recognized.
Thank you, Mr. Chairman. I appreciate the opportunity to listen to these gentlemen before us today and to suggest to all of you here, I'm from Florida, and Kennedy Space Center is in my district, and so I'm really big on solar and sun, as well as NASA and space exploration. So my remarks will be focused for the most part on the solar radiation management, my remarks and questions. But I want to suggest to my friend Mr. Hall that while you might think this is science fiction, I was talking with my daughter yesterday who was telling me my son, who is in China, was saying that they had a massive snowstorm induced by the state of China, or the nation of China. So do you not believe that happened?
I believe that the snowstorm happened, but I don't think you can prove that they caused it.
Okay, all right. Well, maybe it is science fiction. I don't know. But it is interesting, and I suspect if they could, they would. And so I think all the comments mentioned today about the necessity for research and development and international cooperation in so doing are valid and worth great consideration, that it is not impossible and maybe not even improbable that someone somewhere will ultimately take advantage of the scientific opportunity. I would like to see us move forward with research and development, and I appreciate the comment of Dr. Shepard that, you know, be careful what you ask for because you're going to have to wind it down eventually. And as you suggested with the volcanoes, you need to know where you're going next. Nevertheless, I think in this nation, we have both the brains and the capability to move forward on new frontiers as this is. Mitigation, obviously, combined with new opportunities for better ways to produce energy and also to protect the environment, kind of seem like they go without saying. In fact, one of the reasons that I ran for office is exactly that. I think we needed to be moving in a different direction in this country with regard to protection of the environment and conservation of energy and new energy methodology. So I'm pleased to be here and pleased to be on this committee. I wanted to just discuss for a moment with Dr. Caldeira. You discussed in your comments the simulations and small-scale field experiments of solar radiation management. Can you discuss what the simulations and the experiments entail? And, well, let's start with that.
To date, there have been a number of modeling groups using climate models to simulate the effects of deflecting more sunlight away from the Earth. And I believe that all of the simulations that used some reasonable amount of sunlight deflection found that sunlight deflection was able to reduce most of the climate change in most places most of the time. But as Alan Robock points out, after Mount Pinatubo, the Amazon and the Ganges River Delta had some of the lowest river flow on record. And so there are negative consequences we need to be aware of and to study more deeply. In terms of experiments, so far no experiments have gone on in the field, but we could think of process-based experiments. You know, if you did put some material into the stratosphere, what kind of chemical reactions would occur? Would the particles stick together? And so there are a lot of small-scale field studies that could be done short of something that affects climate, and we need to think carefully about how to go about conducting these experiments.
Okay. I know that it has been suggested that the National Science Foundation and DARPA maybe would be agencies. Can you tell me something about your feeling of NASA being involved perhaps in these projects? Yes, sir. I'm sorry.
We use a NASA climate model with NASA computers to do our simulations, and certainly NASA should be heavily involved in the climate research and also, NASA puts up satellites, and we need a capability of being able to measure particles in the stratosphere. There used to be the SAGE satellite, Stratospheric Aerosol and Gas Experiment. They no longer exist. There's a spare sitting on a shelf in Hampton, Virginia. We could
bring it down to Kennedy Space Center, and I guarantee you we'd get it out there.
That's right. And so NASA really needs to be involved in an enhanced Earth observing program that can really help us. I was here in Washington earlier this year at the National Academy of Sciences in a panel, are we ready for the next volcanic eruption? And the answer was no. And Jim Hansen was sitting next to me. He said, no, we need a better capability of being able to observe the stratosphere for a volcanic eruption and for any geoengineering experiments. And NASA could be heavily involved in that.
Thank you, Ms. Cosmos. I think you're going to get some business down there.
Good. Thank you.
And Mr. Robacher, Mr. Hall has been anxious, waiting your 5 minutes.
Thank you very much, Mr. Chairman. And no hearing like this would be fulfilled without my adding a list at this point of 100 top scientists from around the world who are very skeptical of the fact that global warming exists at all. If I would like to submit that for the record at this time. And there you go. Let me just note that there is ample reason for us to question whether or not things that are being suggested today are really needed, because there's a reason to question whether there is global warming, considering the fact that it has not gotten warmer for the last 9 years, and the Arctic polar cap is now refreezing for the last 2 years. But that argument isn't what today's hearing is about, so I will just make sure that that's on the record and in people's mind when looking at some of these suggestions. Let me ask about some of the specific suggestions. I understand that at 9/11, when they grounded all the airplanes, that it actually increased the temperature of the planet. Global dimming. Is that right? And thus,
excuse me, that's not correct.
That's not correct.
There was one study that showed that without clouds from contrails, that the diurnal cycle of temperature went up, that the daily temperature went up, the nighttime temperature went down, but that was later disproven. It was shown that was just part of natural weather variability, so that wasn't a very
Let me note that every time it doesn't fit into the global warming theory, it becomes natural variability, but when it does fit in, it becomes proof that there's global warming. Let me ask you this, so that really wasn't then. Does anyone else have another opinion of vapor trails, by the way? So we have learned today that we really just have, am I misreading you by suggesting that you too are part of the group that believes in global warming, that would like to restrict air travel or try to find ways of eliminating frequent flyer miles? We know you don't want to eat steak now. Are we also not going to be able to fly in airplanes?
Airplanes are one of the sources of emissions. If they use biodiesel and it recycles the fuel, then it wouldn't be part of the problem. But indeed, if we can do some emissions of CO2. We don't have to. These mobile transportation sources are very hard to retrofit on airplanes. With cars, you can, of course, generate electricity with wind and solar. But airplanes, we may still have to keep flying, and we can live with a little bit of CO2 emission if we deal with other sources.
Again, let me note that, by the way, could your scientist here, what is the percentage of the atmosphere that's CO2? What percentage of the atmosphere?
It's 0.039%.
Okay. And most people, when I ask that question, Mr. Chairman, out in the hinterland, people believe it's 25%. And instead of this minuscule, that's 0.03, that is 3% of 1% and of the atmosphere. And there are those who have realized that in the past there have been many times when that CO2 content was enormously greater. Isn't that right? And during that time period there were lots of animals like dinosaurs and lots of things growing, and the world seemed to be doing pretty good.
CO2 concentrations were high in the past, and the biosphere flourished. And, you know, even if we disagree about what the threats are from climate change, and I think we do, that, you know, I don't think my house is going to burn down, but I buy fire insurance. And
but you don't tell your neighbor he can't have steak or visit his kids in an airliner. And that's the point. There's going to be changes.
Right.
People have to understand there are going to be huge changes in our lifestyle. This nonsense is accepted.
I don't believe we're going to solve this problem by asking people to behave differently. Okay. I think we're going to solve it by improving the systems that surround us. But to get back to my point, that you know, even if we don't believe that climate change will damage us, we have to say there's some risk, and so then we have to say, well, how much should we invest to try to mitigate that risk?
We're going broke right now, and the bottom line is that we have very little to invest in theories that may or may not be correct, And we also have a lot of indication that just the fact that you're using the word climate change is a difference than what was used 10 years ago, which was global warming. And most of us realize that's because people now are trying to hedge their bets so they can have these controls whatever way the temperature.
No, I don't think that's true.
At the time,
Thank you very much.
Yeah, speaking of dinosaurs, the time for Mr. Robock has run out, and we will need to proceed to Ms. Dalkemper.
Thank you very much, Mr. Chairman, and I want to thank our witnesses for coming today. This is fascinating hearing, and I look forward to more hearings on this as we delve into this subject further. I have a question for the panel and anyone who would like to address it. Do you believe that any particular geoengineering option should be removed from consideration completely? If so, why? Anyone?
I think we have to think in terms of a portfolio, and that there are some things that are clearly more promising. There are some things that can be scaled up, and on the solar radiation management side, there are things that can be scaled up and deployed rapidly. And I think those two are really particles in the stratosphere and perhaps whitening clouds over the ocean. On the carbon dioxide removal side, there are a bunch of land-based options to increase the storage of carbon from photosynthesis that need to be explored, and also industrialized capture of CO2 from the air, and also spreading minerals around on the Earth. My own view is that other options, such as ocean fertilization, for example, are not going to play a significant role in solving the problem. That's not to say I would put zero money into them. I would just put them way down in the list of my portfolio of investments.
Anyone else? Dr. Robock?
There's been a suggestion to put Frisbees in space, to put a cloud of particles of satellites up to block the sun at a point between the Earth and the sun, and that would probably cost trillions of dollars, and nobody's sure if it would work. So I wouldn't suggest we invest money in that idea.
Dr. Shepard.
Yeah, I would personally exclude from consideration the idea of covering desert areas with reflective material because of the potential impacts on local rainfall patterns, not to mention the environmental impacts on the desert ecosystems themselves.
Dr. Fleming?
Given the hurricane I showed that came ashore, I would also suggest we be very careful about redirecting storms.
Oh, Dr. Caldeira?
I think we need to be clear what kind of research we're considering. That if we're talking about a climate model and somebody wants to say, well, what would happen if we changed the reflectivity of a desert in a climate model, that's a small-scale, non-invasive kind of research that might be good to do. But if somebody wants to start rolling out giant plastic sheets over the deserts, that's something we shouldn't do. So when I'm talking about a portfolio, there's some things that we should do at small scale, maybe just in climate models, and that should receive a relatively low priority.
And I would say there's nothing that we should do right now. We need a lot more research, theoretical research with climate models to see what the benefits but also the risks would be of different suggested strategies. So far, everybody's done a different climate model experiment. It's hard to compare the results. So I'm organizing an international program where all the climate modeling groups in the world do exactly the same experiment so we can see, do they really get drought in certain regions for certain experiments? And if everybody does the same experiment, we can compare it. We'll have a much better confidence that our models are correct, just like we do for global warming experiments.
If we're looking at this climate system being so complex, and you talked about some of the international agreements, what kind of things do we need in place in terms of international agreements and legal steps before we could really do a large-scale testing initiative? Dr. Lane, or Mr. Lane?
Yes, I would pick up on something that I said in my written statement, which is that nations may differ in their interests in geoengineering, at least in solar radiation management, which is the kind we're talking about for the most part here. I would suggest that the United States really needs to learn a lot more about the potential risks and benefits of solar radiation management for the U.S. before it embarks on any kind of international agreement or international protocol. We need to be clear on U.S. interests. Not that that ultimately isn't going to turn into international bargaining, but just each country needs to be clear about its own interests before we're ready for diplomatic bargaining, I would suggest.
Thank you, Mr. Lane. And
Thank you.
demonstrate that the California Republican Party is a big tent. Mr. Bilbrey is recognized.
Thank you, Mr. Chairman. I'd like to quickly yield to the gentleman from the frozen wasteland of Nebraska at this time.
I didn't realize that was a thank you, I guess.
No, sir.
Dr. Robock, following up on your suggestion that mitigating the consumption of beef would help the environment, do you see any nutritional drawbacks to that? Or do you consume beef yourself?
Yes. And no, I'm not an expert on nutrition or on the entire system of agriculture. I've just seen papers that calculate how much greenhouse gases are emitted for, say, a pound of beef versus a pound of pork or a pound of chicken or a pound of potatoes. And just in that one narrow way of looking at it, there is more emitted that causes more global warming from beef.
But a narrow way of looking at it, you're suggesting?
Yes, yes. There's a lot of other considerations. I'm just talking about the impact on global warming.
But you would advocate mitigating consumption of beef as a means of accomplishing your objective?
Yes.
And how would you suggest going about that? In the interest of time, I do want to leave him some time. How would you suggest going about that?
Education. I mean, people. You can't. I mean, it's your job to decide what to tax and what not to tax. Obviously, if you wanted people to behave differently, you give them incentives and disincentives for behavior. But that's just one of the ways that the climate system responds to methane and it responds to carbon dioxide. And the current way of producing beef emits a lot of those gases. That's just what to do about it, what the entire portfolio of mitigation should be. I'm not.
However, I mean, you just advocate for something to mitigate the consumption of beef.
Well, so the way to, if you do want to do that, of course, then you give.
For the record, I don't want to.
I mean, I guess I'm trying not to say something that'll make you feel bad, but I'm trying to also be honest about.
Might be a little too late.
Yeah, sorry.
Well, thank you.
Reclaiming my time, Mr. Chairman, I have stated before, the changing, quote unquote lifestyles or whatever is going to be too little, too late. I want to thank you for having this hearing. The fact is, after seeing what kind of proposal that supposedly was going to address climate change that came out of the political structure here, I've come to the conclusion that we need to talk about mitigation of the crisis because we're not going to avoid it. There's not the political will to do what it takes. There's not the political will even to make it legal in the United States to do what it takes to avoid climate change. So, because I believe strongly that we got to produce, have the ability to produce energy that doesn't emit greenhouse gases, so we can shut down all those facilities that do. And there's not the political will to do with that what we did with the interstate freeway system, where the government went out and cited, did the planning, did the things, so we can shut down the coal producing and the emissions and all that other stuff. We're not willing to do that. We're just willing to talk about how terrible it is. So this is going to be a treating the crisis and trying to mitigate the adverse impact. And I appreciate that approach. The question is, there was a comment, have we now eliminated global dimming as a consideration in this issue?
If by global dimming you mean the effect of pollution,
the cooling effect of particulates
in the troposphere, it's not global, but it's continuing in places that emit a lot of particles, like in India and China. But solar radiation mitigation is global dimming on a global scale. People are talking about putting a cloud in the stratosphere, not down near here where we breathe.
My concern is this, as somebody that's worked on air pollution. I would assume eliminating coal. I mean, clean coal is like safe cigarettes. I'm hardcore against it, but that's fine. But if you eliminate coal, which puts a lot of particulates in, I'm concerned that there may be an adverse impact we don't consider. You got to.
Yeah. If we eliminated coal use today, the Earth would probably heat up by about another degree Fahrenheit from removing the sulfur. If we put just a few % of that sulfur in the stratosphere, we'd get the same cooling effect on a global average while eliminating something like 95 or more % of the low-level pollution. And so we need to think about, what if China were to say, for each power plant that we put sulfur scrubbers on, we'll take 3 or 4% of that sulfur and put it higher in the atmosphere to get that cooling effect while eliminating 95 or more % of the pollution.
Excuse me, Dr. Caldeira. We have about 8 minutes till we have to go vote. So I just want to take a quick to assure Mr. Smith that he can go home and tell his constituents that the beef police will not be knocking on their door, and recognize Mr. Lujan to conclude our questions.
Well, Mr. Chairman, I appreciate that. And as someone that enjoys a T-bone or a lamb chop, sometimes it's raised on the family farm that I live on. And home to wonderful hunting in New Mexico as well, that I'd invite my colleagues to come down to New Mexico to see for themselves. I appreciate the emphasis with mitigation and what we're talking about here. I would say that as we look to see what we have to do as a nation, and what I hope that we're truly looking at here is not telling people they don't have to fly to visit their family, or that they don't have to eat beef, or that they don't have to do whatever it is that is being said today, but that we're telling people we can be smarter about the way that we do things. That we're saying, when we're talking about human behavior, I do not see how encouraging people to be more efficient with their home energy use or with vehicle use or being smarter about things like that doesn't have a positive impact on all that we're looking at. Again, being smarter about the way we do things, being able to embrace ingenuity and challenge our scientists, our engineers, our researchers to continue to do great things. When I was young, I remember watching cartoons about science fiction and this whole notion that people could one day be in space, building a space station, not only walking on the moon, but staying up there for months upon end to do research. And lo and behold, yesterday there were 3 astronauts that came to visit us here on Capitol Hill who came back from making improvements where there's more and more people that are living in space, staying there for months upon end. We're in a global community. We're doing some of these things that were once considered science fiction. We're being smarter about the way we do things, and we're doing them better. And so as we look to see what is happening around the earth, I know that there are many who truly believe that there still isn't a problem, that this isn't something that we have to do something about. And I would hope that we could get something submitted into the record from those of you that are willing to speak to them, to tell us what it is that we can share with them as well, to talk about this problem that I believe that is facing us as a nation and facing us as a global community. As we talk about the science, though, and what it indeed that we can employ to be more aware of what is actually occurring with the warming of the oceans or weather patterns, can you talk about the importance of how we're able to include computer modeling capabilities of research laboratories, of our national laboratories, of our colleges and our universities around the United States that have supercomputing capabilities and have the ability to now use new data to be able to feed you the information that you need so that we can indeed solve some of these problems? Dr. Caldeira? I
and my colleagues did some of the first computer model simulations of these solar radiation management methods at a Department of Energy National Lab, Lawrence Livermore Lab, and the kind of computing facilities at places like Los Alamos and the other labs in the system are really valuable, and we're a great place to be able to do this work. That I'm also, as an academic, a strong supporter of our academic research institutions and the computing facilities at those institutions. And I think that there is potential through investing in this research area to revitalize our science education and the computing facilities that support that education.
Dr. Caldeira, and for the rest of the panel, we're down to less than 5 minutes now. So I will quote, if he doesn't mind, Dr. Ehlers in saying, Mr. Lujan, you brought us to an eloquent conclusion. Thank you for your statement. Before we close the hearing, as I told the witnesses earlier, I will provide for them two questions. One on what should a research program look like, and the second one, if we have any type of international treaties or collaboration, what should that look at? We would also welcome any comments to follow up, Mr. Lujan, or anything else. You have been an excellent panel. This has been I think, an important hearing, the start of a longer-term discussion. And I think that we can say with consensus that no one is advocating that geoengineering is a one-stop shop or any type of a alternative to mitigation, but something that needs to be reviewed. And so I will say now that the record will remain open for 2 weeks for additional statements from members and for answers to any follow-up questions the committee might ask witnesses. The witnesses are excused, and the hearing is adjourned. Thank you. How far apart does Dana and Bilby live?